So we're going to discuss coordination chemistry. Now, I'm using that as a misnomer because I'm really going to focus on transition metals. Those are elements in the D block. You can have coordination chemistry of the S block, that's the alkali metals, the alkaline earth metals, and the metals in the P block. So that's all the metals in the icosagens, the crystallogens, and the pnictogens. However, I'm going to focus on the transition metals, the D block. So there they are, pulled out in all their wonderful glory. We got D block elements in 4 periods. So the 4th period, which is the first row of the D block, so of course that's the one that confuses students initially because you go from the 4S in the 4th period to the 3D for the first row of the D block. But anyway, period 4, first row of the D block, period 5, second row, period 6, third row. And in the middle of that third row, of course, you have the illustration that chemists can't count because they go from 57 to 72. Well, of course, squeezed in there are the lanthanides, or the lanthanoids, if you want to be terribly politically correct. And we see that same thing in period 7 for the 4th row. You go from 89 to 104 because 90 to 103 are down here in the actinides and the actinoids. And of course, collectively, those two are the F block elements. Now, I don't think the A-level curriculum touches on F block elements at all. Indeed, by and large, university curriculums don't until you get into sort of the optional type modules in the 2nd and the 3rd year. But anyway, there are the transition metals. Now, there's a couple of things I should point out while we're still on this slide. First of all, as you go through, you could use the new periodic table, group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11, group 12. You could use the old-fashioned ones, and this was 3A or B, depending on which side of the Atlantic you were, 4A or B, 5A or B, 6A or B, 7A or B, and then you have these ones grouped together as group 8, depending again on which side of Atlantic you were on. Well, the way that we typically talk about transition metals is not really thinking about them in groups. Group 1 we don't want to have confused with the alkali metals and something along here. What we do is we talk about the transition metal triads. Now, of course, you might notice that this leaves out this last one here, the period 7 ones. Well, quite frankly, actinium's pretty awesome, but 104 all the way up through 1012, they've only discovered a few atoms of each of those. It's unlikely that in the lifetime of you, your children, your grandchildren, any significant chemistry will be investigated with these much higher molecular mass elements. They're all radioactive and so on and so on and so on. So I'm going to continue to call things by their triads. So this is one of the big triads: iron, ruthenium, osmium. Another triad that you've seen a lot before: copper, silver, gold, and so on. Okay. Now, finally, this last group here, if you think back to your electron configurations, and I'll have a slide of those just in a minute, these have got filled D orbitals, D subshells. Okay, they're all D10, so 3D10, 4D10, 5D10. And so because of that, you get a lot of people who say, well, they're not transition metals. Well, they're in this transition block. So if you're going to have a transition block, include the transition metals. I'm in the minority there. But quite frankly, if you exclude zinc, cadmium, and mercury from the transition metals, A, what are they? But B, you lose some important conceptual emphasis there. So I'm going to keep calling these transition metals. I'm going to keep calling them D block metals. And if you don't like it, well, you can go and find another video series. Actually, just kidding, but it's always important that you understand why certain things are as they are and what the objections are to them.